Well, let us discuss the Faraday's law of electromagnetic induction in a quantitative manner. That is, we have seen that whenever magnetic flux linked with a coil changes, an EMF is induced in the coil. That is what the qualitative aspects of Faraday's law. And in a quantitative manner, the magnitude of induced EMF is proportional to the rate of change of magnetic flux and also to the number of turns of the coil. And accordingly, we can express it as E equal to minus N d phi by dt, which is the expression for induced EMF. Similarly, we can have the expression for induced current and induced charges. Now, these induced EMF last so long as the magnetic flux is changing. That is what the Faraday's law of electromagnetic induction says in a quantitative manner. And the negative sign here is explained by Lenz's law. Of course, Faraday have also explained the negative sign, but not as in a very formulative manner as that of your Lenz's law. So therefore, Lenz's law popularly takes care of the negative sign. That is, the direction of induced EMF is such that it opposes the very cause of change that is producing it. And this Lenz's law is an electrical analog of Newton's law of action reaction or that of your Chatellier's principle in general. That is, if any state of equilibrium is disturbed, a reaction is induced in such a sense so as to oppose the change. That is what we have seen in Chatellier's principles and action and reaction in Newton's law. This is very much similar to that of your Lenz's law. In this process of changing flux, that is what we see, the mechanical energy is converted to electrical energy. That is why the opposition are there. I mean, whenever you have a north pole is approaching, a north pole is formed in the vicinity of the coil, as we have seen, or whenever the north pole is receding away, a south pole is formed at the vicinity of the coil, and same for the south pole approaching or receding, as we have seen. So therefore, these two things are vital to start with for further discussions in problems in a formulative manner, and before that we will also see in our next discussions, that is methods of producing induced EMF, how we can produce these changing magnetic flux, that is with respect to time, how the magnetic flux can be changed, we will see in a subsequent discussion. As because we know phi is equal to the magnetic flux is linked with magnetic field and area and also with orientations, there is various way how we can change with respect to time by changing area, by changing magnetic field, by changing orientations, and even by changing the number of turns we can change the magnetic flux, and accordingly we will have various formulations for working out problems in related to electromagnetic inductions so far as the Faraday's law and Lenz's law together are concerned. We will see in our subsequent discussions. Thank you.